Okay, welcome to lesson 2.4. This is covering section 2.2 in our textbook, and we're going to be talking about normal calculations. So given that you have a normal distribution, finding percentages from values and finding percentages from values and values from percentages. So going both directions. So I'm going to show you on here how to use a calculator, but more importantly, I'm going to show you how to use a table. I do not want you really using a calculator till we're probably through into next semester. But when we're trying to find values between standard deviations, so they don't fall exactly at one standard deviation or two standard deviations away, we must use a calculator or a table. Okay. When finding percentages from values, we use the normal CDF function on the calculator. When finding values from percentages, we use the inverse normal calculator command. So let's see how this works. And again, I am not going to go through the calculator commands because I've got it here, but I don't know how many people have calculators available right now. The table I am putting out in Schoology for you, so you will have it. And this is how I really prefer people to do it. So if we're taking an IQ test and you get a score of 124, we're assuming things are normally distributed. So remember those 3 steps we had last time. With a mean of 100 and standard deviation of 15, what percentile are you at? Okay, so first we're going to draw our curve. So here we go. So there's 100, and we label this is normal, the mean of 100 and a standard deviation of 15. So again, we always want to put that, and we always need that capital N to indicate it's normally distributed. And I score 124, or you score 124. I want to know what percentile is that. Okay, well, how am I going to find this? I'm going to use my z-scores to do this. Okay, so again, this is not using the calculator. So the first step was to draw this and label it. I've done that. I now need to see the percentile. So to do that, I'm going to calculate my z-score. And remember, z-score is your individual data point, which is 124, minus the mean of 100 divided by 15. That gives us a value of point, is that right? Let me just double check this using a calculator. And I was going to tell you the wrong value. So 124 minus 100 divided by 15 is 1.60. And I'm going to round to 2 decimal places, and that's going to be important when you see how I use this table. Okay, so the way we use this table, this is table A, standard normal probabilities. This table will always give you the percentile, and it's going to show the probability of this finding this area that's under here. So all these values in here are probabilities. This is your z-score. So this is negative 3.40, negative 3.41, negative 3.42. So we just add this last decimal place onto whatever we have right here. Now, I have a z-score of 1.60, and I knew it was above, so that makes sense that it's a positive value. It's a good sanity check. And if we keep in mind where my one standard deviation was, that was about right there, is 115. So I knew that my z-score had to be bigger than 1, but here would be 2 standard deviations at 130. So since this is between 115 and 130, that's 1 standard deviation, 2 standard deviations. It's somewhere between these, and I want to see the percent. Well, notice it didn't fall on one of those exactly, so that's why I'm using this table. So I have a z-score of 1.60. So I'm going to come over here, and the positive z values are on the right, the negative ones are on the left. So I'm going to come over here, and I'm going to come down here looking for 1.6, and the 0 I'm going to find up at the top, so the last decimal place. So 1.60 is right here. I get 0.9452. that is 0.9452 is the percentage as a decimal. So this equals 94.52 percentile. Hopefully that stayed on the screen the whole time. So what percentile are you at if you score 124? You're at the 94.52 percentile. Okay? So again, I'm taking my z-score, finding it on the table, and that gives me my decimal, my probability. Okay? What if I want to go from a value to a percent? So what score do I have to earn on an IQ test to be below 88% of the test takers? Okay, so that's kind of strange. I'm not sure why I want to be below 88%, but okay. We are assuming they're normally distributed with a mean of 100 and standard deviation of 15. Of course, that doesn't change. So again, same 3 steps. There's my curve. There's 100. And I need to say it's normal with a mean of 100 and a standard deviation of 15. So we label it every time. Okay, and I'm looking for what score. So that's an individual data point. Well, if I want to be below 88%, I need to be over here on the left somewhere. So I'm just going to call that X. I don't know where exactly it is. So what I need to do is I want to be below 88% of the people. So that means I want to be at the 12th percentile or lower, right? Because 100 minus 88. So 100 minus 88 equals the 12th percentile. So I'm going to, again, come to my table here. So I want to find the 12th percentile. So I am looking now in the probability section. And I'm looking under the negative side for z's. And I'm looking for where I find 0.1200. So I'm looking for as close as I can find to 0.1200. And as I'm coming here, let's see, here we go. We're getting closer. I see a 0.1210 and a 0.1190. Well, when it's right between them, you just have to take one or the other. And there's no set reason why you would take one versus the other. So I'm just going to go to 0.1210. Okay, so that is a z-score of negative 1.17. And hopefully you could see that. So I'm going to use 0.1210 gives me a z-score of negative 1.17. Okay, so I've got my z-score. Now I'm going to work backwards to find the x value. So remember, our z-score is equal to the individual minus the mean divided by standard deviation. So z equals individual, or I'm just going to call it x minus mu over standard deviation. So negative 1.17 equals x, because I don't know that, minus 100 divided by 15. And here's where you get to do some algebra. So those of you who are thinking there's not enough math and stats, here we go. Multiply both sides by 15, and then I will add the 100. And I get x is equal to 82.45. So I would need to score 82 or lower to be below 88% of the test takers. Again, I don't know why you'd want to do that, but that's how you would do it. So we can, if we have a value, we'd find the z-score and then find the probability and convert that to a percentile. If I need to find the value and I have a percentile, I look inside the table, convert the percentile to a decimal, look for the closest value for that decimal, and then go out and upwards to find the actual z-score. Okay, let's take a look at some more problems here. We'll just do a couple more, and then we'll do some practice. So key points, whenever we're dealing with a normal distribution, the first thing you want to do is draw and label, calculate, and then answer. Percentile is the percent below a data value. And if we hear the words at least, that means we want the data value and above. So if I wanted to score in the 75th, at least in the 75th percentile, it means anything above 75% would be fine. And inverse normal, when you, and again, this is just a calculator thing, but when you input the area, it is always the area below, or the percentage below. To approximate an upper bound, and again, these are all just calculator things here. When you input the largest bound, you need a very large positive number and a lower bound number, because we can't put in negative infinity, you would use a negative value. And again, don't worry too much about that. Next semester, we will get into the calculator use quite a bit, or once we're back in face-to-face. Okay, so let's take an actual problem here. Mensa is supposedly the organization of geniuses, and they calculate that as those people who score in the top 2%, so more than 2 standard deviations away from the average. So what we want to know is, what score would you have to get to qualify for Mensa? So you have to be in the top 2%. So first thing we're going to do is draw our little chart, which hopefully you're getting very comfortable with. So 100 is our mean. This is my IQ score. And we say normal with the center at 100, standard deviation of 15. Okay. And we must score something. So I don't know what the X value is. But if I want to be in the top 2%, I'm going to be somewhere over here. And I'm just going to put an X here. So if I'm in the top 2%, what percentile is that? Or what percentage is below that? So there's got to be 98% below. So I'm going to be looking for 98 percentile in my table. So again, I have the percentile. I'm going to be looking for 0.9800 in my table. And I know this is going to be to the right, so it's a positive number. So on my table, I'm looking under the Z positive values. And inside here, I'm looking for something close to 0.9800. So 0.97s, oh, there we go. I have a 0.9798 and I have a 0.9803. You typically go with the one that is closest to the value you want. So in this case, 0.9798 is only 0.02 away from 0.98. So I'm going to use this value. So that gives me a z-score of 2.05. Okay, so let's get my little z-score here. So this gives us a z-score of 2.05. And now I work backwards from that. So z equals my x minus mu divided by the standard deviation. So 2.05 equals x minus 100 divided by 15. When you do that algebra, if I've done this correctly, hopefully, we multiply both sides by 15 and add 100, and we get x is equal to 130.75. So in other words, we need to score 131 or higher to join Mensa. Okay, and let's take that question a little bit further. There are 328 million people in the United States. How many members, or Mensa geniuses as they call themselves, live in the US? Well, we know that they're the top 2% of the IQ test. So I'm going to take my 0.02, so that's 2% as a decimal, multiplied by the number of people. And that will get me the number of approximate geniuses in the United States according to IQ measurements. So 6,560,000 people. are, quote, and I definitely would put that in quotes, are geniuses. So again, I took my percentile, converted it to a decimal, and then multiplied by the total in the population. And as our discussion question, we're going to talk about intelligence. Can you identify intelligence using data? Is it possible to just get a single number to define someone's intellectual ability? And think about whether you can identify or cannot identify intelligence with data. And we will talk about that in class. Okay, good luck.